Section 5.6, half angle identities. In the following identities, the plus or minus symbol indicates that the sign is chosen based on the function under consideration in the quadrant of the angle A over 2. Okay, so half angle identities, that means that your angle that you're working with is half. Okay, so A over 2. So we want to find the exact value of sine of 22.5 degrees using the half angle identity for sine. Okay, so here, sine of 22.5 degrees, this is sine of A over 2. So that means that A over 2 equals 22.5 degrees. Okay, 22.5 degrees is in quadrant 1. Okay, this also means that A is equal to 45 degrees. Okay, so just 22.5 times 2 gives us 45 degrees. So if we set this up, we have sine of 22.5 degrees. So sine of A over 2 is equal to plus or minus 1 minus cosine A. Okay, so A is 45 degrees, so 1 minus cosine of 45 degrees over 2. Okay, so we have plus or minus 1 minus cosine of 45 degrees is square root of 2 over 2. Okay, so we're just going to simplify, so we have plus or minus, so 1 minus square root of 2 over 2, this can be written as 1/2, so 1 over 2 minus square root of 2 over 4. Okay, so that gives me 2 minus square root of 2 over 4, which is equal to plus or minus the square root of 2 minus the square root of 2 over 2. Okay, so here I just took the square root of 4 in the denominator. Alright, so we are in quadrant 1. Okay, so in quadrant 1, sine is going to be positive. So then our answer is going to be the square root of 2 minus the square root of 2 over 2. Find the exact value of tangent of 75 degrees using the identity tangent of A over 2 equals sine A over 1 plus cosine A. Okay, so A over 2, so this is tangent of A over 2 here. A over 2 is equal to 75 degrees, which is in quadrant 1. So then A would be 75 times 2, which is 150 degrees, and that is in quadrant 2. Okay, so using this identity, we have tangent of 75 degrees is equal to sine of A, so A is 150 degrees, so sine of 150 degrees over 1 plus cosine of A, cosine of 150 degrees. Okay, so that means tangent of 75 degrees, sine of 150 is 1 over 2, and then 1 plus cosine of 150 is negative square root of 3 over 2. Okay, so that gives me 1 over 2, and then 2 minus square root of 3 over 2. Okay, and then I'm going to rewrite this as 1 over 2 times the reciprocal, so that would be 2 over 2 minus square root of 3. So then I get 1 over 2 minus square root of 3. Okay, and then we have to rationalize our denominator, so we're going to multiply by the conjugate. So we multiply by 2 plus square root of 3 over 2 plus square root of 3. So This gives me 2 plus square root of 3 in the numerator, and then 4 minus 3 in the denominator. Okay, so it's 2 plus square root of 3. 4 minus 3 is 1. So that means tangent of 75 degrees is 2 plus square root of 3. Okay, and it should be positive because we're in quadrant 1 and all trig functions are positive in quadrant 1. Example 3. Given cosine s is equal to negative 3 over 7 with s in between pi and 3 pi over 2. Okay, so this is quadrant 3. Find sine of s over 2, cosine of s over 2, and tangent of s over 2. Alright, so we're given that s is in quadrant 3. Okay, but remember our sines come from the quadrant of whatever a over 2 is in, or in this case, s over 2. So if s is in quadrant 3, s over 2 is going to be in quadrant 2. Okay, so finding sine of s over 2. Let's do that first. So we have sine of s over 2, which is equal to plus or minus square root of 1 minus cosine s over 2. Alright, so remember that we are in quadrant 2, so sine is positive in quadrant 2, so we're going to keep the plus sign. So sine of s over 2 is positive square root of 1 minus negative 3 over 7. Okay, so I just pulled cosine s from here, over 2. So that gives me 1 plus 3 over 7 over 2. Okay, so that is the square root of 10 over 7 over 2, which is the same thing as the square root of 10 over 14. Okay, and then we simplify this fraction so that we have sine of s over 2 is equal to the square root of 5 over 7, which is equal to the square root of 5 over the square root of 7. Okay, and then don't forget, we don't want to leave radicals in our denominator, so we're going to rationalize. So multiply the top and the bottom by square root of 7, and sine of s over 2 is going to give me square root of 35 over 7. Okay, cosine of s over 2, this is equal to plus or minus 1 plus cosine s over 2. Okay, again, we're still in quadrant 2, and cosine is negative in quadrant 2. So this is going to give me cosine of s over 2 is equal to negative square root. Okay, and we have 1 plus negative 3 over 7. Okay, so cosine s comes from up here again. That's what we were given in the equation, over 2. So that gives me negative square root 1 minus 3 over 7 over 2. Okay, so it's negative square root of 4 over 7 over 2. Okay, and then 4 over 7 divided by 2 is the same as saying 4 over 14. Okay, so the negative square root of 4 over 14, just as we did in the previous portion, we're going to simplify 4 over 14. So that gives me 2 over 7. Okay, and then don't forget to keep bringing your negative sign down up front. Don't let that get left behind. Alright, so that's going to give me the negative square root of 2 over the square root of 7, which we will then need to rationalize. So cosine of s over 2 is equal to the negative square root of 14 over 7. Alright, and then tangent. So we want to find tangent of s over 2. So tangent of s over 2 is equal. Okay, so you can use the formulas that were given for half angle identities. So any of these. You could also, so we don't know what sine A is. We do know what cosine is, cosine S in this case, because that's what we were given. So you could use this formula. But for these, we don't know what sine A is. We only know what sine of A over 2 is. So similar to what we did in the previous section, tangent of S over 2 is equal to sine of S over 2 over cosine of S over 2. Okay? Because tan theta is equal to sine theta over cosine theta. And in this case, our theta is just S over 2. Okay, so you can always go back to this quotient identity. So tangent of S over 2 is equal to, so sine of S over 2 we saw previously as square root of 35 over 7. And then cosine of S over 2 is the negative square root of 14 over 7. Okay, so if I rewrite this as a multiplication times the reciprocal, I have square root of 35 over 7 times 7 over the negative square root of 14. This gives me negative square root of 35 over square root of 14. Okay, and just like we did above, we have to rationalize this. So multiply by the square root of 14. And then tangent of s over 2 is going to give us a negative square root of 490 over 14. Okay, and then we're not done yet, because you can see from here that this square root of 490 can be simplified again. So this is the same thing as 49 times 10. And the square root of 49 is 7. Okay, so this does simplify to negative 7 square roots of 10 over 14, which then 7 over 14, then it simplifies into negative square root of 10 over 2. Okay, so then tangent of s over 2 is equal to negative square root of 10 over 2. Alright, example 4. So A, we have plus or minus the square root of 1 minus cosine of 8x over 2. So the identity that this is using is sine of A over 2 equals plus or minus the square root of 1 minus cosine A over 2. Okay, so notice that A is equal to 8x. Okay, so that tells us that A over 2 would be 8x over 2, which would be 4x. Okay, so A over 2 is 4x. So that means that sine of A over 2 is going to be sine of 4x is equal to plus or minus 1 minus cosine 8x over 2. Okay, so our answer here would be sine of 4x. Okay, identity here is tangent of A over 2 equals plus or minus 1 minus cosine A over 1 plus cosine A. Okay, so these have to be the same angle. Okay, so here A is 9 beta. So that means that A over 2 is 9 beta over 2. Okay, so that means that tangent of 9 beta over 2 is equal to plus or minus 1 minus cosine 9 beta over 1 plus cosine 9 beta. So our answer here is tangent of 9 beta over 2.